Alright, so let's go on to the proper lecture part after that preamble. And today's first lecture is about input handling. And I should unfreeze this so you can see what I'm doing. Maybe. Right. For your future reference, the input handling lectures are preceded by a little description of how to do that thing that we just did, where slightly modified form. But I'm just reminding you how to build up this little pipeline where you translate, scale, translate back. And I've done it with this version where you actually put parameters on to specify the positions, and where we use the default coordinates as a way of translating back to the origin. But it's the same story as we just ran through. It just, again, it might turn out to be relevant. Right, inputs. So remember, when we were doing the main loop, we spoke about how the main loop is basically gather inputs, update simulation, and render stuff and do outputs, right? So we're going to look at inputs just now. So what happens is that the user inputs, whether they're coming either from like a real physical user or from an external source over the network or something like that, they arrive on the computer in the form of events, or at the hardware level, actually hardware interrupts, but you don't need to know about that. And depending on the kind of system you're working for, it might be that you can kind of ask the system for those events. You can do things like query the state of the keyboard, or the system might tell you, it might be that it tells you that things have happened, like a key's been pressed or released, and you react to the change. And in the case of HTML5 stuff, it's the second one, it's react to change. It tells you that things have happened, and you decide whether you care about them enough to do anything. There's an interesting little subtlety here, that when you're capturing the input state, when you're kind of updating a frame of your game, in a polling system, like the way old computers or old games machines used to work, you could kind of query the state of the joystick at any time. You could say, well, is the X button pressed right now? And sometimes that would cause problems if you had a piece of logic where, let's say the X key meant do jump or something like that. So you would have a piece of code that say, if the X key's down, then give the guy some velocity because he's doing a jump. But there might also be logic that says, if somebody's doing a jump and they collide with something, then make them try and climb up the wall or something. So there'll be another piece of code in the collision system that says, well, if there's a collision, is he pressing X? If so, do the climb thing. The thing is that technically, between those two queries of is he pressing X, he might have let it go. Maybe at the start of the frame he was pressing X to do the jump, but by the time you were doing the collision check, he just happened to have let it go, and the second one wouldn't quite trigger. And you can sometimes get problems because of inconsistencies like that. So a thing that I always recommend is, if you're going to take the input state of the system, try and copy all the inputs right at the start of the frame. That's kind of why I've got the gather inputs idea. So what you would do there is, in the gather inputs one, you'd say, is he pressing X? Is he pressing Y? Is he, what's the current state of the controller? And you would store that away somewhere and then use that consistently for all the logic, rather than repeatedly asking the same question of the hardware, because you might get slightly different answers. Just worth bearing that in mind. So that is kind of describing a polling system where the OS knows what's going on and you ask it at any given time, what's going on right now, where is the mouse, is the W key pressed, those kind of things. But we're actually using an event-based system because the web is very event-driven. And what happens here is that you simply get told that an event has transpired and you have to remember what happened. So, for example, you might want to say, is the W key pressed right now? The browser doesn't really give you a way of doing that, but what it does is it gives you a way of saying, let me know when the W key is pressed and let me know when it's released. So you just track those two things, which means that when it's pressed, you have to remember, you have to store somewhere the fact that the W key is down, because it won't really tell you again, with some caveats. And then your code would just check that variable, say, is the W key down right now? And then when they let it go, there'll be a key up event, and you use that to reset the flag, so you know that the state has changed. So that's what you have to do. The way all this works inside browsers is that while your page is running, these events are being handled by the OS, and they're coming into the browser and they're being processed. Basically, they get put into a queue, and they the events just kind of sit there in the queue waiting to be processed until your code is finished running. The events don't happen while you're doing something else in your page. So what happens is you need to run your function to update the next frame or draw the screen or whatever it is. And while you're doing that, that's all that's happening. But when that function finishes and there's nothing left to do, then if there are events that have been queued up in the meantime, the OS will process the browser will process those. So it looks like this. You've got your call stack. If you imagine this is just a crude map of the memory, right? So your call stack frame describes the contents of one function. You know about function frames? Yeah, that's what this is. So you've got a bunch of functions, and every time a function gets called, you stick on another frame, and every time it returns, one comes off. Right? So this is where all your code. So this is the main function, which is calling the update function, which is calling the doodad function, which is calling the whatsit function. So they're just sitting there. And meanwhile, there's a queue here of events that are coming in as messages, and you've got a whole bunch of general objects, just things that you've allocated in memory. And when you stop running your function, these frames go away, and the messages get processed, and they sometimes cause new functions to get executed, and those functions are event handlers. You actually probably know this if you've done kind of web work or event systems, but I have to tell you just to be on the safe side. In fact, how many of you do know this? How many of you know about listener events and things? Have you done that kind of stuff? Right, okay. I'll maybe speed up a bit. So have you seen this before? Event listeners on Windows? Right, brilliant. Okay. So this is how you do it. Take the window object, say I want to know about keydown events, and when a keydown event occurs, you want it to call this function. And when the key up event, you want to call this function. So that's what you do. The contents of those functions, you have choices as to what to do, but I would recommend something a bit like this. Well, this is a very simple version. So when the key down event gets called, it gets called with a special parameter called EVT, which is the event, and it contains a key code that lets you know what key is actually pressed. Now, the key codes by default for simple cases are just basically the ASCII value of the key that was pressed. So what I've done up here is I've created a sort of a would-be constant called key underbar x, and it's simply the string x, and I ask it for the character code at position 0. So I'm basically saying, what's the ASCII value for x? Because it turns out that if you press the x key, the event key code is the ASCII value for x. For the characters that are like ordinary alphanumeric characters, that's the way it works. For other ones like the cursor keys, it's different, and unfortunately can be inconsistent between different browsers. But this is a kind of fairly safe thing to do. So here we have a key down handler. We just check whether the key happens to be the X key. If it was, I do some stuff. So this is me drawing a rectangle and telling the console that we pressed X. Simple enough. You also notice I had to resort to a global variable here. I use a global variable for the context. Now, as you probably know, generally speaking, global variables are kind of a kind of ugly thing that you want to avoid. But I kind of had to do it because this function, I didn't get to decide what its parameters were. The system did that, and the system says its only parameter is the event. So if I want to do anything outside of that, I need to get a hold of the world so I can do something. So in order to make this work, I had to make the context a global object so that I could then actually do some drawing work. And there's a convention that I follow, which is quite common. If you make a variable global, you put a G underbar on the front of it, just so that it jumps out, so that when you're looking at a function, you realise, oh, look, he's using an ugly global variable. And the ones that don't have G underbar are, either parameters or local variables, and that's fine. But you kind of want your global variables to be conspicuous because they're like something you want to try and minimise, and they are a bit special. So this is just a nice way of making sure that they stand out. Incidentally, if I really wanted to avoid the global variable here, there are some tricks I could use, but I'm not going to do it. It's too much of a detour. Right. So that was a very simple way to just handle the X key, but what you really want to do is something more like this. You want to handle any key and combinations of keys. So you might want to know, is the X key down and is the W key down, or is the P key down? So the way that I suggest doing this is you create an array for all the keys. And then when a key down event comes, you take that array and you find the particular key code that corresponds to the key, and you just say, okay, true. So that's you just saying, this key, whatever it was, is now down. And then you might want to do some stuff. If there's some logic that you wanted to do, like if you wanted to, draw a rectangle, you would draw it. And then when key up occurs, you just go to the same thing, you go to the key code and you say false. So as a result of this, we can have a simple array of keys that tells us at any time which keys are up and which keys are down. And in order to initialize it, you do this somewhere, as we've seen, and you just set all that up. So that's keys, but we might also be interested in the mouse. Mouse events are a similar story, so you can see the analogy is quite close. What you do for mouse events is you just add one listener called a Mousemove Listener, and the event that comes into the mouse thing has got a bunch of information, particularly the client X and Y coordinates. Now it turns out to do this right, the client X and Y are the X and Y coordinates relative to the window itself, but you want them relative to the canvas, because it's not quite the same thing. The canvas might not be right at the top of the window. So you do this thing where you take the sort of window coordinates and you subtract off the coordinate of the canvas itself. So you end up with a position relative to the canvas, which is what you'd want to know. So that's very simple. And now we know we have now some more horrible magic global variables that tell us where the mouse is at any given time. Which leads me on to your homework. I've got there quicker than usual. The homework today is to take the default smiley that you just made and modify it so that it becomes a generalized smiley that you can draw anywhere, as per what I just showed you, but also allow it to be controlled by the keyboard and the mouse. So we've now got objects being controlled interactively in real time. It's almost like a game. I know it's not quite a game yet, but we're getting there. So this is a bit more dynamic than what we've seen up till now. Yes? Yeah. So I'm going to show you what I want it to look like, kind of, which is, but I think I'll maybe take a separate recording to do that for people that just want to jump to seeing what the homework's supposed to look like. So I will come out of this and I will just stop for now, but only briefly.